Welcome to Biology of Marine Mammals. I'm Dr. Leslie Williams, and this is the first of many lectures to foray into nutrition and foraging strategies. In this lecture, we'll introduce you to the concepts of nutrition, specifically looking at caloric needs and metabolic rates. We'll evaluate food sources and how those food sources might contribute to a marine mammal's diet. And finally, we'll look at the cost and benefit of doing foraging. Foraging, of course, means to eat. So with foraging, you need to find, capture, and handle your food. So we'll look at how much that costs versus the energy obtained from different food items. You may already understand the idea of calories. In fact, if you've had any interest in nutrition at all, you may actually understand that different humans have a caloric need. So this is the daily food requirement in calories that is needed to sustain a human. Now, the caloric requirement for a person is going to change with several factors. This includes age, which is mostly related to size, somewhat with gender, and also with activity levels. For example, most adults require between 1,800 and about 2,400 calories per day, but that variance is largely attributed to how much activity that person does in a day. If you have somebody who's rather sedentary and spends a lot of time sitting, they may only need 1,800 calories a day, versus somebody who's training for a marathon may actually need upwards of about 3,000 calories per day. Whereas when you get to the smaller humans, such as children, they actually require less. So small children may only require 1,000 calories per day for a 2 or a 3-year-old, and infants even less than that. So just like all humans have a particular caloric need, so do all animals. So when we look at marine mammals, we're going to be looking at what their caloric needs are. Before we get into what the caloric needs are, we need to go back to the concept of metabolism. Recall that metabolism is going to be the collection of chemical reactions that happen within a body. So most of these chemical reactions are some sort of combustion of food molecules. So the higher the metabolic rate, the more chemical reactions are happening, which means the more starting food molecules you need. Therefore, it stands to reason that if you have a high metabolic rate, you're going to need more calories. In other words, if you need more energy, you're going to need more food. And of course, calories is a convenient way to measure the amount of energy stored up in a food molecule. So because marine mammals are going to be concerned with maintaining or achieving their caloric daily requirement, we are specifically interested in what types of things are going to increase the metabolic rate for those marine mammals. So again, the higher the metabolic rate, in other words, the more energy they're expending, the more food they're going to need to consume in terms of calories. So what are some of the things that would increase the metabolic rate for a marine mammal? Well, any type of vigorous activity will do it, and this includes, of course, swimming and diving. So when we think about animals that are swimming vigorously, for example, they actually are going to have a higher metabolic rate than animals that tend to be more sedentary, such as the sirenians, which are the manatees and the dugongs. And of course, diving also expends energy. And if you don't have a favorable buoyancy, in other words, let's say you're positively buoyant and you're trying to dive very deep, you're going to have to spend a lot more energy achieving that dive than an animal that is negatively buoyant and sinks pretty much without effort. So all of those are considerations, as well as any type of long-term activity such as a migration is going to have a higher energy expenditure with it. We learned earlier that marine mammals tend to have a higher basal metabolic rate, in part because they have to generate more heat. So when we look at a marine mammal versus a terrestrial mammal, they tend to have higher metabolic rates simply because they lose so much heat in water versus a terrestrial mammal. And of course, this is exemplified with a sea otter, which has a very high metabolic rate because they don't have a lot of good insulation. They rely only on their fur, and they tend to be fairly small. And this is another thing: the smaller you are, the more heat you're going to have to generate because you don't have as much insulation or a favorable surface area to volume ratio. And finally, something we haven't talked about yet is that there is energy associated with reproductive costs. Now, this really is much more on the female side of things than the male side of things, but if you're a female marine mammal and you are going to gestate, which means to carry a baby and allow that baby to grow in your uterus and then give birth and then nurse that baby, you actually are going to have to spend a lot of energy doing that. So for example, as a pregnant human, which I am, I actually have to consume more calories than I would normally. Somebody of my stature might normally consume about 1,900 calories per day, but being pregnant, it's probably closer to about 2,600 calories per day, and that's going to continue even after I give birth due to breastfeeding. The production of milk is energetically expensive as well. So any female marine mammal that's in a reproductive state of some sort is going to have a higher metabolic rate than a marine mammal that is not working on caring for a newborn or gestating. So with that metabolic rate, I want to turn back to the idea of size, because we're going to go back to the fact that size, of course, matters. And when we look at marine mammals, as a rule, we see some very interesting trends associated with size. So here's the deal. The larger you are, the more calories you require. But the relationship is not linear. And to highlight this point, I want to compare an adult male versus a newborn. If you take an adult male who's about 160 pounds, then maybe that caloric requirement is going to be 2,100 calories per day. When you actually do the mathematical division, this means that each pound of that adult male's body requires 13 calories per day. So we say 13 calories per body pound. If you contrast that to the newborn may only be 7 pounds and only requires 500 calories per day. And you say, but that's considerably less. Yes, but when you do the mathematical division, you realize that to support a pound of newborn, it's actually 71 calories per body pound. So in other words, there's the age-old adage, it takes more energy to run a gram of mouse than a gram of moose. The larger you are, the more calories you do require, but the more calorically efficient your body becomes. In other words, it's not going to take as many calories to run a pound of that body as opposed to a smaller body. So with that in mind then, we go back to this idea of why marine mammals are usually very large. And we've looked at several selective pressures that have kind of favored a larger body, including the fact that they have better heat conservation, you're going to avoid predation better, you're going to be able to swim much more efficiently, etc. But also here now we add into this argument that metabolic rates are going to be more favorable if you're larger. Yes, you will require more calories, but you're going to have an increased caloric efficiency. In other words, if you take a mysticeti, which is a baleen whale, 10 times the volume of an odontoceti, which is a toothed whale, the baleen whale isn't going to require 10 times as many calories, maybe only 2 times as many calories. So it may be more favorable to be that large whale because that large size allows you to obtain twice the number of calories as the odontoceti quite easily. So this is what we mean by increased caloric efficiency. So with that in mind, what we're going to do now is we're going to turn and look at some of the different food items. So what are some of the food items that might be available to our marine mammals? Well, just like with humans, not all food has the same caloric value. So when we take a look, for example, at fat, fat tends to have more caloric value than protein or carbohydrates. Similarly, different food items are going to have different values. And you might notice that when you're looking at some of these, krill, which is a type of shrimp, fish, squid, and seagrass, and you look at the values here on the screen, we're no longer talking about calories, we're talking about something called kilojoules. Kilojoules tends to be the more international way to measure energy stored up in an organism or a food, and as a rule, 1 kilojoule equals about 1/4 of a calorie. So you can make the conversions if you like, but kilojoules tends to be what we use. So obviously on this list here, seagrass is going to have the lowest caloric value, whereas fish tend to have higher caloric values. So of course, You might say to yourself, well, then I want to eat the food with the highest caloric value, which of course makes sense. And if you take a look at where you might get your calories in a given day, and you start looking at the different options, you realize they're quite variant. So if we say that a marine mammal requires X number of calories per week, you could have 6,000 pounds of seagrass, 3,000 pounds of squid, 2,000 pounds of krill, 1,000 pounds of fish, a seal and 2 penguins, or half of a gray whale calf. So what are you going to pick to eat? Well, it really depends. The easiest, of course, you might say is, well, I'll take half of a gray whale calf because then I'm done. In other words, I don't have to work anymore to get my food. Chewing 6,000 pounds of seagrass seems pretty awful. But you have to weigh that against the cost of actually getting that food. So when we talk about food sources, we need to look beyond just the number of calories a gram of food provides. We have to look at the energy that is expended to actually get that food. So where are we expending energy? It could be that you expend energy locating food. If your food is mobile, you might have to pursue it, and that takes energy. Capturing food may be difficult, particularly if you're trying to capture something as large as a seal, a penguin, or a gray whale calf. And of course, there might be energy expended in processing that prey item, as sea otters often do with shelled mollusks. They actually have to work to break them open to get at the meat. So all of these energy costs associated with finding and capturing and obtaining your food must be substantially lower than the actual value of the prey, or you're going to starve. So you might say, yes, I want to go ahead and get that half of a gray whale calf to sustain my weekly caloric budget. But if you're not successful in capturing one, then you've wasted a lot of energy trying and you've got no gain at the end, then you're going to starve. And so on that sense, a lot of animals have adopted not to go maybe for that higher caloric value, but to go for things that are easier to find and have a lower caloric value, simply because the cost associated with getting them isn't so great. So that's kind of the summarizing point here as we look at the cost versus benefit. We know that all marine mammals are going to have a high caloric need. This in part is because they live in water. And it's not uncommon for a marine mammal to consume anywhere between 4 and even 25% of its weight per day. But how you select your food source is going to be a balancing act. You need to balance the availability of that food item, how difficult it is to locate and capture that food item, and remember, deep diving needs to be a consideration. Giant squid are nice and calorie rich, but you got to dive very deep to go ahead and get them, against the caloric value of your prey. So we'll look at two extremes here. On one end, we have the sirenians, which are the dugongs and the manatees, which go for the easy to locate, easy to capture, but low caloric value seagrass, versus the other end, which is going to be the orcas. Many orcas will go after seals, penguins, even a gray whale calf. Despite the fact that it has such a high energy expense associated with it, they're willing to risk that for the great reward of the calories. And with that, I will see you next time.